Let's continue talking about the SD-Access. In this case, we're going to talk about the overlay. In order to understand how the overlay works, you will need to know Lisp, VXLAN, and some of network access control and scalable growth tags. So let's go into it. Remember that these terms are used interchangeably, overlay and fabric. And in these diagrams, I'm going to use the or show the control nodes and the wireless LAN controllers directly connected to intermediate nodes just for schematic purposes. Because remember that control nodes and wireless LAN controllers are usually located in your shared services block, where your DNS servers live, where your DHCP servers live, where the DNA center that is now known as Catalyst Center lives, where the I server lives, and so on. So this is only for schematic purposes. Let's first talk about Lisp, which is the routing protocol for our overlay. Do not confuse this with the routing protocol that we are running in the underlay, which can be either EIGRP, OSPF, or ISIS. In this case, given we're going to use tunnels in order to create our moving traffic across the SD-Access network, we need a way to find where is the destination of each tunnel, and Lisp is used as a routing protocol in order to locate tunnel destinations. If you already know Lisp, and you should, you just have to know only that, for instance, the control node performs the roles of being the map server and map resolver for this network. So remember that the control node performs the functions of a map server and a map resolver. In a normal Lisp network, these functions can be divided in separate devices. For SD-Access, the control node will perform the functions, both functions in the same device. And the edge nodes are XDRs. So as XDRs, if you, for instance, connect here a device, this device responsibility is to register this device with the map server, which in this case is the control node, and it will use a map register message in order to do so. So with the map register message, we will register this device's ID, which is the IP address of the device, and we will map it to a router locator or an RLOC. In this case, the RLOC will be the loopback IP address of the edge node. For the border nodes, you have to remember that border nodes are proxy XDR. Remember that border nodes connect our network to external networks. For instance, a data center. And if, for instance, you are using the all the prefix 172.16.0.0/16 for all your devices within your data center, these border nodes will register that prefix with the control node using a map register message as well. And so, for instance, they can map the EID 172.16.0.0/16 to the loopback IP address that belongs to the border node. There are some prefixes that the border nodes will not register. For instance, internet prefixes will not get registered to the map server, which is the control node. For instance, the default route is not usually registered. And what else? For wireless users, the process is a little bit more complicated, because the wireless LAN controllers will be in charge of register those users to the map servers, which are the control nodes, using a map register message, but that map register message will point to the edge node where this user is being served through the access point. So this is a little bit different. This works a little bit different for wireless users, but at the end, wired users and wireless users are mapped into edge nodes. Let's talk about VXLAN now. Remember that another protocol that we use in the overlay is VXLAN, and this is a protocol that helps us create tunnels on the fly, be it between border nodes and edge nodes, or between edge nodes and edge nodes, or between access points and the edge node where they are connected. So if you already know VXLAN, you know that you need VTEPs in order to encapsulate and de-encapsulate the tunnels. And in this case, the border nodes are VTEPs, the edge nodes are VTEPs, and the access points are also VTEPs, but with the particularity that the access points will only create VXLAN tunnels with the edge node to which they are connected to. Remember that SD-Access is strongly focused on security, so we will need a special server that is known as ICE that will help us do all these security chores. For instance, when we connect a device here to an edge node, this edge node becomes a AAA authenticator, and it will have to perform network access control. And then it will have to use ICE as a AAA server in order to authenticate this device. Once authenticated, ICE will provide an scalable group tag and a VNID to the traffic coming from this device. So with the users of the VNID or virtual network ID, we can actually separate traffic depending on users. So I can have actually virtual networks. For instance, I can have a virtual network for guest users and a virtual network for enterprise users. This is one way of doing it. You can create virtual networks over one physical network, and the traffic get assigned a virtual network ID, so you can separate that traffic and know to what virtual network that traffic belongs. That traffic can be either layer 2 or layer 3 traffic. And I'm going to assign an scalable group tag in order to later on apply an scalable group tag, scalable group access control list to that traffic, which is the similar way of applying access control lists for legacy networks. So as you can see, you will need an ICE server for your SD-Access network to work. This is the workhorse of the security in your SD-Access network, and you will need the Catalyst Center, formerly known as a DNA Center, in order to create those policies and push them into ICE. So the device that is doing all the work is ICE, but the device that you need in order to create those policies is the Catalyst Center, formerly known as the DNA Center. So when creating our tunnels, we will need Lisp in order to locate these destinations. Please help me find this destination for these tunnels. We will need VXLAN in order to create a tunnel to transport layer 2 or layer 3 traffic. And then we are going to use VXLAN headers, the VXLAN headers, in order to transport the virtual network ID and the scalable group tag. So this information will travel through the VXLAN headers of each tunnel. This works great within my SD-Access network, but if I am moving traffic outside the network, and I need to maintain this information, the virtual network ID and the scalable group tab. I'm going to have to use inline tagging or SPX, which are trustsec Cisco technologies, in order to maintain this information and as this traffic travels outside the SD-Access network, outside my fabric. So as a summary, the overlay, which is also known as the fabric, is a tunnel-based network. We're going to use Lisp in order to locate tunnel destinations. We're going to use VXLAN in order to encapsulate and create tunnels for layer 2 or layer 3 traffic. We are going to use VXLAN headers in order to transport the virtual network ID and scalable group tags that belong to each packet or frame. And remember that when using virtual networks, we have something that is known as macro segmentation. And when applying a scalable group access control list to our packets or frames, we are achieving micro segmentation of security. That's it. The next session. In the next session, we're going to talk about what are the exact functions of each device role.